Welcome to Spaceverse, your portal to cosmic adventures. These are questions that have probably been with us since the very beginning of human existence. How did the universe come into being? What came before? And perhaps the most haunting of them all, are we really alone? For generations, we've searched for answers in the stars. The James Webb Space Telescope, often simply called Webb, was supposed to bring us closer to solving these mysteries. It was built to look deeper into space, to see further back in time, and to help humanity understand its cosmic origins. And while it has indeed provided breathtaking insights, Webb has also done something unexpected. It has thrown almost everything we thought we knew about the evolution of the cosmos into question. The discoveries it has revealed are not only astonishing, they're also deeply unsettling. Webb has uncovered enormous cosmic structures that, according to our most trusted models, simply should not exist. And this leaves us with uncomfortable questions. How do we deal with discoveries that contradict everything we thought we understood? Can we still rely on our established theories if Webb's findings keep tearing them apart? Or, to put it more dramatically, could it be that the universe did not begin with the Big Bang after all? Stay with us until the end as we explore this gripping cosmic mystery and uncover how the impossible discoveries of Webb are rewriting science before our eyes. Whether you're a die-hard space enthusiast or just casually curious, chances are you've already heard of the technological marvel that is the James Webb Space Telescope. With its massive 6.5-meter diameter mirror and 4 highly advanced infrared instruments, Webb is the largest and most powerful space observatory ever built. It's not just a replacement for Hubble, it's on a whole different level. In some cases, Webb is even 100 times more sensitive than its legendary predecessor. Webb was specifically designed for infrared astronomy, which makes it perfect for peering through cosmic dust and catching faint light from the earliest galaxies. Its mission: to take our understanding of the universe to a completely new level. Among its goals are studying the formation and evolution of galaxies, investigating black holes and stars, and even examining exoplanets for signs of habitability. But perhaps its most ambitious task is to observe the very first luminous objects and galaxies that appeared after the Big Bang, peering back some 13.5 billion years into the so-called cosmic dark age. This is a period we've long theorized about but have never been able to witness directly. With Webb, we finally can. And yet, as powerful as our theories and models are, they are only useful if they reflect reality. And what happens when reality proves them wrong? Webb's discoveries have left scientists scratching their heads, sometimes even admitting with humility, "We have discovered the impossible." To be fair, mistakes in science are nothing new. A quick glance at history shows that even our brightest minds have stumbled. Our ancestors once believed the Earth was the unmoving center of the universe. Even Albert Einstein, one of the greatest physicists of all time, initially thought the cosmos was static and unchanging. So convinced was he that he actually added a cosmological constant to his equations to force the math to match his belief. Later, after realizing the universe was in fact expanding, he called it the biggest blunder of his life. And yet, despite these missteps, some ideas have seemed so solid that they've become cornerstones of modern science. Chief among them is the Big Bang Theory. According to the overwhelming majority of astronomers, the universe began 13.8 billion years ago, not with an explosion into space, but with the rapid expansion of space itself from a singularity. Matter, time, and energy all emerge from this tiny, hot, incredibly dense state. We can trace this conclusion back to the expansion of the universe itself. If space is expanding, then by rewinding the clock, we inevitably reach a single starting point, a singularity where density is infinite and all distances collapse to zero. Supporting this, we have the detection of cosmic microwave background radiation, which is essentially the faint afterglow of the Big Bang. It's an ancient relic, a snapshot of the universe when it was only 380,000 years old. But while we're confident about this broad picture, the details of how galaxies formed after the Big Bang remain one of astronomy's great mysteries. Our fundamental assumption has long been that the earliest galaxies must have been small and relatively undeveloped. The first stars likely lit up 200 to 300 million years after the Big Bang, but when and how these stars organize themselves into galaxies has been less certain. What we did know is that the galaxies forming so soon after the Big Bang should have been tiny compared to today's giants. At least, that's what we thought until Webb rewrote the script. The surprise came when Webb revealed galaxies that existed just 300 million years after the Big Bang. At first, this lined up with expectations. These galaxies were indeed small, low mass, and relatively primitive. But shortly after, Webb identified 6 other galaxies of a similar age that didn't fit the model at all. These weren't small. These were enormous, so massive they rival our own Milky Way. Astrophysicist Evo Lab, who analyzed the data, recalls his shock vividly. "I ran the analysis software and it spat out 2 numbers. Distance, 13.1 billion light-years. Mass, 100 billion stars. I almost spat out my coffee. I knew we had just discovered the impossible, impossibly early, impossibly massive galaxies." Let's pause for a moment. Imagine this. Our Milky Way has taken 13 billion years to become what it is today. Yet Webb was looking at galaxies that already reached similar mass levels just a few 100 million years after the Big Bang. According to our current knowledge, this is simply impossible. There wasn't supposed to be enough matter or enough time to build such giants. Together with his team at Swinburne University of Technology in Melbourne, Lab analyzed images taken by Webb's NIRCM instrument, targeting a section of sky near the Big Dipper. This region had been observed by Hubble, but Webb's sensitivity revealed something new: reddish, shimmering points of light at staggering distances. By measuring redshift, the stretching of light as the universe expands, researchers concluded that this light had traveled over 13 billion years to reach Earth. The galaxies had to have formed only 500 to 700 million years after the Big Bang. But instead of finding fragile baby galaxies, they found colossal galactic giants. Each of the 6 galaxies had more than 10 billion solar masses worth of stars, with one potentially nearing the incredible mark of 100 billion solar masses. Joe Lea from Pennsylvania State University initially thought there must have been a mistake in the analysis. But no, every calculation checked out. The galaxies were real, and the mystery was undeniable. Could they be something else, like dust-shrouded black holes? Possibly. But even if that were true, it would still imply that the early universe contained far more stellar matter than any of our models predict. As Erica Nelson, one of the study's co-authors, put it, "Even if only one of these galaxies is real, it pushes our understanding of cosmology to its limits." And so the so-called universe breakers were discovered, galaxies that break our theories and force us to rethink everything. To explain their existence, either the early universe was far denser than we thought, 2 to 5 times more matter packed in, or galaxies formed in ways we simply don't yet understand. Either explanation requires rewriting major parts of cosmology. American astrophysicist John Mather, who has dedicated his career to NASA, summed it up candidly. "The first galaxies grew differently than we expected. And we don't know why all the predictions were wrong. And these 6 galaxies were just the beginning." Webb has since revealed even more perplexing objects. Additional massive galaxies at high redshift, galaxies with unexpectedly mature shapes, and even evidence of surprisingly advanced chemical elements. These findings suggest multiple generations of stars must have lived and died incredibly early in cosmic history. Webb has also offered surprising insights into the epoch of reionization, the period when the first stars and galaxies transformed the universe from a dark, neutral state into a light-filled one. In some galaxies, Webb has detected an absence of neutral hydrogen where it should have been abundant, hinting that this transition happened much faster than we believed. So where does this leave us? The James Webb Space Telescope has already accomplished its mission of revolutionizing our understanding of the universe. It's shown us that the formation of galaxies, stars, and cosmic structures happened earlier, faster, and perhaps in completely unexpected ways. Our theories aren't wrong so much as incomplete. Just as Einstein's static universe was eventually corrected by the discovery of cosmic expansion, our current cosmological models are now being reshaped by Webb's eye-opening discoveries. And the most exciting part? This is only the beginning. Webb has many more years of exploration ahead. Who knows what other wonders it will reveal? The James Webb Space Telescope has shown us that the universe is far stranger and far more mysterious than we ever imagined. If galaxies can break the rules of cosmology, what other secrets are still waiting out there in the dark? One thing is certain: our search for answers has only just begun. This is Spaceverse, where the mysteries of the cosmos come alive. Don't forget to like, subscribe, and join us on the next journey into the unknown.